This is going to be something like a coffee break / workshop. So it's going to be full casual, but at the same time you will get all the necessary information how to be a node operator, not just for Ternoa, but for other Polkadot chains or subset chains to be more precise. Uh, it's when you look at it, it's quite simple, but there are some steps which are not really fully defined, and that's why it will take more than 1 hour. Go through all those steps that you get, the basic foundation, and then we will build. Hi, Rike1610, and follow. Again, I apologize if I am mispronouncing your names. That's just how it is. Yeah, so we will do the workshop. The workshop is basically done in two parts. The first part is to run a node operator on your either local machine or your VM. It's up to you to choose. You can follow along. And the second part of the workshop is going to be how to set up the staking part. So you have some DevOps work, setting up the node and the VM or your local personal PC, and doing the staking part, which is done through the Polka UI, which is quite easy to use. Since this is going to be quite a long workshop, we're going to have a short break after the first part for like 5 or 10 minutes for me to relax, because English is my mother language, and it can get exhausting if you're talking in a foreign language for 2 hours. So yeah, we'll have a short break. I will put some, I don't know, banner or something. I don't think we have any kind of commercials. Maybe if I find my Ternoa bot, I'll show you guys. But yeah, a beer break. Yeah, that would be really great. But sadly, I don't have any beer nor wine, which is super sad. But yeah, I have my water with me. It's a Croatian one. It's with gas, carbonated, so it's going to be enough for to make sure that I go through this and that we learn something. But yeah, let me just recap what I said. This is a workshop about node operators. How to set up a node, how to set up a validator, how to do the staking part, and that's all. Any other questions which can be out of scope, if I can answer them, I will answer them, okay, immediately if I see them. Just make sure, guys, this the stream is kind of lagging on Twitch, like 10 seconds. So hi Lulu Crypto. So if I don't answer immediately, it's because again it will take time myself to organize and to find the right answer. Any other questions which I cannot answer, like I said, I will just ignore it, and then the support team, they will take care of it. Sadly, I don't know. I'm just a dev guy, okay? I don't know some projects that Ternoa has, because I didn't work in them. Ternoa has at least 3 or 4 projects. One of those projects is the blockchain itself, and I'm part of the blockchain project. But there is also the some rewards project too. I think Launchpad too. But I never worked. I was never part of that system, so I cannot answer any questions regarding that. So yeah, sorry guys. You can still ask them here. The support team will handle it. But yeah. So, Mr. Ouroboros, I hope again I'm pronouncing your name correctly. So you don't have. He said. I don't have a real question, but more recommendation, advice. When Ternoa caps will be ready, probably do a lot of memes about Musk. So yeah, there are a lot of interesting memes to do. I think Morpheus is the latest meme from last month, I think. But yeah, we'll do some really interesting memes, I hope. But again, we will see. Okay, yeah, guys, before we start, for you all newcomers and early comers, you have now the chance to earn a prize by participating, blah blah blah, whatever, in a game, where you need to pick the most handsome Ternoa guy. Okay, so I will tell you how it works. So yeah, I will share my screen. Okay, share screen, Chrome tab. Yeah, let's see. Okay, so the goal is to visit the Ternoa.com/team, and out of all those guys, you need to pick the most handsome one. Okay, I'm not going to tell you who that is, of course, that would be cheating, but pick one and send the answer to one of our support guys, Kevin, or Guillaume. If you can write the email that the guys can send you, so they can get something. So there are three categories. So the first person who answers correctly will get a prize. The second person who answered correctly but wasn't the first will also get a prize, but randomly. So by second, I mean if I myself have picked the right person, but I was the fifth or sixth person who did that, I still have a chance to win something, because we will do it a bit random. And the third category is fully random. So even if you have completely answered it completely wrong, you still have a chance to get a prize. Now, since we need to start really small, the prize is basically you're going to get a postcard from Croatia. So I will send you from my local town where I currently live. I will send you a postcard, and this is going to be kind of really interesting present, because it's kind of in a way not used anymore. I saw that my friends are not anymore sending postcards, but in this way you will get something from Croatia if you never have been in Croatia, and it can be quite interesting. So yeah, please find the right pick up the most handsome guy. What's the URL? Okay, so Mr. Undisclosed 17, I hope. Yeah, it's Ternoa. I will send it here. It's Ternoa.com/team. Yeah, I think that's the right link. Yeah, pick the most handsome guy, send a message to one of our support team, and if you get lucky, you will get a postcard from me. I will handwrite a message just to you, a real lovely message with a lot of hearts, and that's it. Ternoa.com/team. Let's see. I think I did it correctly. So Ternoa.com/team. Let's see. Oh yeah, the link is okay. Yeah. Mr. Peshwar 9. Yeah, they're all super handsome, but one of them is the most handsome. Okay. Some of you guys know, but yeah. Yeah, that's true. So MN2X0 or O, that's correct. One of the questions in our interviews is basically this: who is the most handsome one? If you immediately say the correct name, you will get hired. That's it. There is no additional questions. Okay. Yeah. So let's start with the actual part. Why are you here? You want to be a node operator. You want to be part of this workshop. Buckle up your seats, guys, and let's go. Okay, I will just put my phone on vibration so that you don't get this annoying sound, and I need to share my screen once more. Just 1 second. So share screen, window. Yeah, no, entire screen. Okay, so what I will suggest you guys, so if you are following this, I will send you the link to the workshop itself. You probably already saw it, because I think I have sent it already a couple days ago, but that doesn't really matter. I will share it once more. It's going to be in the chat. So in the chat you can find the link to the workshop itself. If you don't have enough time to be in the whole workshop, because it's going to take quite long, I think 1.5 hours or 2, you can just go through this workshop and you will understand the first part of how to be a node operator, and that's how to set up a validator. Also, the whole stream that you see right now is going to be on YouTube, if I'm not wrong. I will probably upload it today or tomorrow in the morning. So yeah, if you miss something, you can always rewatch it again tomorrow on our YouTube channel. So yeah, let me start the slideshow. Let me move myself. Let me remove the banner, and let's start. Of course, where to send Discord or Telegram? Both options are fine. Once you send a message, we can see the timestamp. So yeah, I need to highlight the message. So Florian underscore DUs asks where you need to send the answer. Discord or Telegram, both options are okay. Yeah, because we can see the timestamp on when you have sent a message, so we can do all those categories or whatever. Yeah, okay. So let's start. How to be a node operator for beginners. Yeah, so in the first half, like I said, we're going to talk about some basic terminology, and we're going to set up a validator for the AlphaNet. So the difference between setting a validator for AlphaNet or for a mainnet is just one single line. Basically, you need to tell the system to connect to the mainnet instead of AlphaNet. So everything else is literally the same. There is no difference. Okay. The correct term is being a node operator. If you say you're a validator, that's two. If you say you're running a node, that's two. But I think the correct term in this community or in subset community is being a node operator. You're operating a node, which can be on a VM or your private machine or whatever, or you're buying it or you paid someone. Doesn't really matter. But yeah, we're going to talk about some really basic stuff, like super basic. If you think that this is work, you can just skip it to the last part. But yeah, we're going to talk about what's a binary, what's a runtime upgrade, what are author or session keys. We're going to talk about what kind of nodes we have, and then we're going to go to the juices part. We're going to configure the client or set up the node, and we're going to configure the server if we have the time. Okay. The next part that we're going to talk about, and it's not part of this presentation, but we are going to talk about is how to do the basic staking. How to stake, how to be to be a validator, and what are elections and blah blah blah. But yeah, once we go to this point, we will actually discuss it. Now the questions is how to be a validator basically. And yeah, there are things that we are not going to cover with this workshop because we don't have infinite time to actually cover everything. It will take 6 hours maybe. So yeah, we're not going to talk about how to set up some node telemetry and metrics. There is a separate guideline for that. I will send you a link for that. We're not going to talk about how to make the node super secure. I'm not going to discuss if you should be a validator or nominator. I'm not going to discuss what kind of VM provider to choose. There are many of them. AWS, Scalaway, I think Google has one too, whatever. I'm not going to discuss it. It's up to you to choose. And of course, why did the chicken cross the road? We're not going to discuss that, and what VM configuration to use. Also, this is not part of this workshop because if it was, it would take hours and hours to actually have the workshop. Okay, let's start with the first subject. How to, what's a binary? What the heck is a binary? So on every side you will see the keywords, which are quite important, and basically you can look at them as buzzwords that you hear every day on our Discord or Telegram group. And those keywords are binary, node, client, validator, and WASP. Those are right now for this section the most important keywords. So yeah, so I will move. Yeah, okay, so I think I'll switch my screens because it should be easier for you. So let me just do that. 1 second. Yeah, I'm using 2 monitors and I want to make sure that I'm looking at you and not, like I'm doing right now. So I'll just share my screen once more. Share screen, first one. I will turn off my Slack, my Telegram group, so that we will get notified, and Discord too. And yeah, let's go back, start slideshow. Okay, now I should be looking at you. It should be more natural. So yeah, what's a binary? Just like a factory worker uses a manual to build a chair, in the same way, an operating system, in this case computer, uses a binary blob to build and run applications. Depending on what kind of work you do, your end product can be named a chair, or a music instrument, or a balloon, or a car. The same principle we can use here too. In our field of work, the product of running a binary blob is called a node, a client, or a validator. So those keywords, those names mean the same in this context. So if you're saying you're running a client or a validator or a node in this context right now, okay, it's completely the same. Okay, so instruction manuals can come in many different formats. It can be in English, it can be done using musical notes, it can be written as math expressions. The same can be said for computer world, in the computer world, where many different formats exist, and one of those formats is WASM. WASM is nothing more than a machine-readable binary form of a cooking recipe in Hebrew. Yeah, it's a bit, I think it's really super clear what I meant to say, but when you hear WASM, it's nothing special, okay? It's just one format of explaining something, one way of showing something in the computer world, of course. Just like you have, musical notes to express music, just you have, algebra to express mathematical expressions. The same way you have WASM to express what the computer needs to do, what it needs to do, and yeah. So how does this, binary look like, and what's inside it? It's basically this. This is how the binary looks like. It's basically a bunch of zeros and ones, which, for our perspective is completely useless. We want to see how it works, how it looks like for us. So this is an example of a software client. Like I said, client, validator, node, binary. They're in this context, they're super, they are the same. So basically, in the binary or the client, you have some components that talk with each other, and then in the storage part, you have the WASM runtime, which is right now for you guys who are going to be data operators, super important, because every time we do a runtime upgrade, we're going to update the WASM runtime, which means that you don't need to shut down your nodes; they can still be running. But if we do some work inside or outside the storage, like if we change something in the RPC or the consensus or telemetry or in the P2P network, then you need to get the latest binary from a GitHub. Okay, this is a normal procedure. Other substrate chains do it, like Polkadot, Kusama, and Moonbeam, and you will see that they do a release on GitHub, and they state that this release is of high priority, and all the validators and all operators, they need to update the binary. Okay, this is something completely normal. So no, we are not inventing anything new. Here you can see the native runtime. You can completely ignore that because it's we are not going to talk about it. So what's the runtime, or what's the storage? Runtime is a computer construct that is quite similar to a human brain. It has memories of past events, it knows what's happening right now, and it has a predefined set of rules that it always follows. Telling a sad story to a normal human being, the normal happy human will transition his state of mind from happy to sad. In the same way, runtime will transition itself from doing nothing to creating an NFT if we tell it to do. A system that has visible, known, and reachable state patterns is called a finite state machine, finite state automata, state machines, and there are a couple of more those keywords. So if you talk with someone and they talk about runtime and talk about state machines, yeah, that's it. So the runtime that I showed you in here, the WASM runtime, that's the brain of the chain. All the logic that's happening, all the state transitions, it's happening in here. Okay, everything else is just here to help the chain to run. Like storage, you need to store the block somewhere, and you need to somehow communicate with other nodes. That's the other component. That's why we have the other components. But the logic itself, the brain itself, it's this small WASM runtime. Okay, so a runtime that is built using the WASM format is called WASM runtime. I think that's quite easy to understand. Okay. Now, just like a human brain is stored inside a human skull, the same way the runtime is stored inside a storage container. If we are not happy how the brain or the runtime thinks, we want to change it for a better version of itself. The act of changing is called running a runtime upgrade. To be more precise, we remove the existing binary runtime blob with a new and a better runtime blob. If besides the thinking we are not happy with what information it holds, no, instead of perceiving Alice as a good friend, we want to perceive her as a deadly snake. We can do that by doing a storage runtime upgrade, where we, besides the logic of the state machine, we change the storage too. So if I go back to this graph, if we want to add additional functionality like additional features, and I don't know, NFT, super extreme lending or something like that, or nested NFTs, we will do that by doing a runtime upgrade and add additional logic in the WASM runtime. Now, if we want to change existing storages, like you have this NFT data on the blockchain and it has 4 or 5 fields, and you want to add additional ones or remove existing ones, then you need to do a storage runtime upgrade. This can be quite risky because you're modifying, oh hello guys, BZH, you're modifying existing storage, and if you do it wrongly or in a really wrong way, you can kind of break the whole chain. So runtime upgrades are most of the time safe, but storage runtime upgrades where you change existing data, it can get hairy. Okay, so how does a state machine look like, and where is this runtime placed basically? So this is how it looks like in any finite state machine. It's basically a set of states and a set of triggers. So you can be in the off state, and if a on trigger is triggered, it goes to standby, and from standby you can go to off. This is how a state machine looks like, and it's the same in the code. So in the runtime you have basically the same. Example would be you want to meet NFT. This triggers the state machine in the runtime to go from doing nothing to actually executing a transaction or extrinsics, doing some operations. And in cases where there is some kind of error, we will show it and cancel the extrinsic. Yeah, like Kevin said, I will just show his message. If you have any questions at any time, literally any time, please write it in the chat. If you prefer to ask a question directly and you want to join this podcast or stream or whatever, just contact Kevin and tell him that, and I will send you the link to this stream, and you will join me and you're going to be next to me. Okay, so either ask a question in the chat, or we can talk kind of face to face. And yeah, okay, so yeah, we talked about WASM runtime, we talked about where it's located inside the storage. So yeah, so let's continue. Now this is some basic information about how it works, how the binary looks like, what's the runtime, because you probably heard those keywords a lot of times on probably on Discord more than on Telegram. But yeah, another set of keywords that are quite important to understand are the session keys and the author keys. Okay, so in our life we came across with many decisions and activities that require our signature. This can range from signing work contracts, government documents, or to forge parents' signatures to go to a class trip. The signature represents the authority that stands behind the document, and since signatures are unique and always different in a slight way, we can be sure that the person who signed the document is the right one. In the blockchain, we have activities like producing blocks, finalizing blocks, that also require signatures, because otherwise we will not know which node did what, and we would not be able to trust any single node. So yeah, this is kind of heavy, but bear with me. The example I think is quite clear. A lot of things in your life, not a lot of things, but in certain cases you need to put your signatures as well. Most of the time you have a contract with your telecom provider, with your housing lease or something like that. You need to put your signature, and this means that you have signed it. This signature is you. Okay. The same principle we have in the chain itself. There are some really heavy mathematical stuff going on, especially for producing blocks and finalizing blocks. And the actors who are participating in those activities, they need to be able to sign their work so that later someone can check what has been done and see who has done it. Okay, that's basically those algorithms. They need some public keys and private keys, blah blah blah, and we need to provide them those keys. Now there are currently 4 such systems that require special signature besides Babe and Grandpa, sorry. We have the system that checks if a node is online, which is called I'm online, and the system which discovers other authorities, which is called Authority Discoverer. That also requires special signatures. They're also required. Those signatures or keys can be used separately, but what is more common is to generate one single key that combines all those keys together. The combined keys are called authoring keys or session keys. Okay. Yeah, okay. So the question is, what is this from Zandonia? The question is, what is this live about? It's about being a node operator. I think you can see in the name of the Twitch, stream, you can see the name is coffee break / or dash being a node operator. Okay. Besides the session keys, we also have authority keys. Authority keys combine the session keys together with the staking stash and control accounts, and to produce one key to actually define the whole node itself. So besides the session keys that you need to have for all those algorithms, you also need to have controller and stash account. And if you combine everything, you get this amazing thing called authority keys, and more about that later. Okay, so it's important to know that the session keys that are generated by node can only be used by that node. You cannot generate session keys on one node and use it for another node. Generating those keys also mean that they are at the same time saved in the node's database. The node's database, besides blocks, also stores the session keys as some networking information. And those session keys can be generated in 2 ways, either through Polka UI or by calling our RPC command using a terminal. But more about that later. So if you want to know how it looks like, how those session keys looks like, it's basically a huge string. That's it. This is how it looks like. It's hard really to see all those separate keys in here. But if you look at how it is structured, it's basically a structure which has 4 components. So the grandpa ID or the key, Babe key, I'm online key, authority discover key, those are the session keys. And then you have the authority keys, which is different than the authority discover keys. It's basically everything from the session keys plus the session control account. This might seem super confusing, and that's okay, that's fine. It's just for me to help you to show how it looks like in the code. Now, before we start to configure the client, we will talk about what kind of nodes we have. And before I start to talk about it, I will just take a sip of my water, because I think I'm already speaking for half an hour or even more, and I need a really short 1-minute break. If you have any questions, feel free to type them in the chat, or if you want to talk with me, tell me and I will invite you in this call. Okay, let's go. So what kind of nodes do we have? So there are 2 major ways on how we categorize nodes. The first way is to categorize them by amount of blocks they store, okay? So if you're running an archive node, we will store all the blocks that existed from the start of the chain, so all of them. This means that this will take a lot of storage space. Like example would be that I think the Ethereum chain, it uses 10 terabytes of storage. For Polkadot, it's about I think 100 and something gigabytes, and for Kusama it's 300 or 600 gigabytes. Yeah, I think it's 600 gigabytes of storage space that you need in order to have archive node there. So it consumes a lot of data. But yeah, that's what you get when you store all the blocks on one machine, or I mean on your machine. If you're running a full node, the storage is pruned and we will store only the last 256 blocks by default. You can of course configure that. You can you can store only one block or 256 blocks or 1000 blocks, it's up to you, but you don't store all of them. Okay, you just remove the old ones that you don't need. And the third type of is a light node, which doesn't store any block at all. Basically a light node connects to either a full node or an archive node, most of the time on archive node, and then it gets the information from the archive node. Okay, the light node will only have the current storage and that's all, but it will not contain any previous blocks. And if you query light node, it will first ask archive node to get that information, then it will show it. Now the second way to categorize them or the nodes is by the work they do. So basically we have validator nodes and non-validator nodes, which I call public nodes. Basically validator nodes are responsible for producing and finalizing blocks and running elections. Since those activities require the node to have access to all the blocks, validator nodes are automatically also archive nodes. Okay, if you want to be a validator, you need to have archive node. Okay, there's no other way. Since those nodes used to work for the network, they can be rewarded if certain conditions are met. So what you will see when you become a validator and when you stake, you will be getting money basically if you stake enough and if you became an active validator. But we will talk about that in the second part of this talk. The least common nodes are non-validator nodes or public nodes. They're used as a bridge between the validator nodes and applications that want to run queries or execute transactions. Those nodes cannot be rewarded for the work. So if you have a non-validator, non-archive node, you cannot be rewarded. Okay, the blockchain cannot reward you at all. There are a couple of reasons why would you run a public node, but mostly you're not going to run them. Okay, running them in a archive node, full node, or light node does not change the way it operates, only the way it stores the blocks. So you can have a public node, it can be an archive node, but if you don't set it as a validator node, it's not going to be a validator. So like I said, this is one way to categorize. You can be an archive full node or a light node, and this is the second way. You can be a validator node or public node. As a public node, you can be anything. You could be archive node, a public archive node, a public full node, or a public light node. But as a validator node, you need to be archive node. Okay, I hope this is clear. Okay, there's some certain other information, like what kind of information do we store in the database. We have the blocks itself, some the key store where we store our private keys for signing, the block production and block finalization, and some network information, but we'll just skip this because it's not that important. But yeah, let's start with the why you came here basically, and that's how to run a validator. So we'll go through all the steps, like all of them. There are many of them, and if you want, you can follow along. But it's not really required because this stream is going to be uploaded to YouTube, so you can check it at any time. So yeah, let's start. So now we have some basic knowledge on what are nodes, how they look like, and what kind of nodes we have. Let's start with actually deploying a node. So what I would suggest to you is, if you're following me, connect to your VM. And if you are not connecting to your VM and you're doing this on your private machine or your private PC, you don't need to do anything. Okay, but for the guys, yeah, I need to copy and paste the commands. Where are you? Okay, yeah. So what you need to do is, if you have a VM, you need to SSH to it. I recommend that you pass this server alive interval 60 flag, which means that your connection is not going to die after 10 minutes of idling. Okay, it's going to at least stay for an hour or way more. So what I saw from the test net is that people were connecting to their VM, but since the VM was kind of idle, there was no user input, the connection they got disconnected, right? So this should make sure that you will not get disconnected. Okay, so I will copy this. I will close Signal. I will close Firefox, and yeah, I will connect to one of my machines. This is not the right node. I will find the right. Sorry, this is not the right IP. I will find it off screen, so that you guys cannot fiddle with it. And it's this one, yeah. Okay. Yeah, I hope you can see my terminal. So we will do just SSH root this, and we need to make sure that we copy this part -o and then server alive. Okay, let's see. I don't think I have ever connected to this machine. As you can see, that it's asking me to authorize this, which means that I never accessed these machines. So it's a completely empty machine. I didn't do any work here. Okay. Sure. Okay. I didn't do any work in here. Yeah, Motion said, I hope I'm pronouncing your name correctly, Moshan. Yeah, you can get the IP, but you cannot connect because you don't have the SSH key stored there. Okay, what you need to do is you need to get the binary first, okay? Because the binary is the node, is the validator, is the code that we want to run. And a couple of ways how we can do it. One way is to, where are you? Okay, just seconds. One way is to get it from our bucket, yeah, scalable bucket, but I will suggest you to just go to GitHub, /capsulecorp/chain. I will send the link in the chat, and click on releases. What you want to do, you want to look for a full release which has a binary. So I think the latest one is, or the last one is this. Yeah. So if you click on assets, you will get the binary. You will click on it, and then you will save it. Obviously, I already have it in here because I was trying before, and that's basically it. Now we get the binary, and then you need to SCP the binary to your machine. Okay, and before we do that, I will just create a folder in the directory opt Ternoa, so that you can see what's happening. Or actually, yeah. So I'll go to opt Ternoa. I will go here. I will go to downloads. I'll need to zoom in. I will SCP. This is secure transfer. You're transferring one data from one machine to another one, and in this case, I want to transfer the Ternoa binary to this address. So 172.172.172.184. Yeah, apologies for typing it super slowly, but how it is. That's how it is. And you need to then, after that, you need to do a semicolon. You need to put a path that you want to store the and it's going to be in opt Ternoa. Wow, this is using. And now let's wait for it to be uploaded, and it's already done. Since I have a fiber, it's super fast. And then here we will see inside the Ternoa folder we have this Ternoa binary. Now, what you will see that it's not really executable. And before you do anything, so once you get the binary, make sure that you make it executable. You can do it by chmod u+x Ternoa. Okay. Now your binary is going to be executed, and then you can execute it. Now, one part is the binary, and the second part is actually you need to store the data, the block somewhere. For that, we will create a folder. Okay, so here we create a folder called node data, where we're going to store all the node information. So what I'm going to do right now is I'm going to execute the binary, okay, and I will pass some flags which are necessary in order to be a validator. So the first flag which is necessary to be a validator is the validator flag. So this tells the binary to act as a validator, so it's going to be a validator and archive node at the same time, and this is what we want. The next flag is, I think, the name of the node. I suggest something unique. In this case, I will write, let's see, workshop banana. The next is where we're going to store the node data. I will just open my trusty, where are you? Here. I'll just close this. I will open my helper and I will just look for the command. Yeah, it's here. So the name, the path, okay, is this one. So this tells the system where to store the node data. So it's base path. I apologize. And in my case, it's Ternoa node data. And we need to tell which chain to use. So in this case, since we're going to connect to the AlphaNet, we'll write --chain AlphaNet. But if you want to be a mainnet, validator, you will write here mainnet. Okay. Instead of AlphaNet, you write mainnet, but in this case, we'll do AlphaNet. AlphaNet. Okay, I hope I did it correctly. A couple of additional flags that you need to pass, and there are two of them. So briefly, there are some bugs in the the substrate code itself, and in order to avoid those bugs, you need to pass those two flags. The execution wasm means that the node is going to be a bit slower, but it's going to be working correctly. Again, this is something, it's a bug that by they I mean Substrate has, and I hope they will fix it quite soon. Okay, and I think we are good to go. So validator, workshop, banana, base path, the path we're going to store on the node data, chain AlphaNet, and everything should be correct. And let's try. So it says the role is authority. This is what we want. The name is correct. Let's see, we are running the AlphaNet-1, which is correct, and right now we are syncing up the chain. Now, what I suggest to you is to visit the telemetry link, which is in the workshop itself, and here you should see your node. Okay, in this case, the name of my node was workshop banana, and I can see here, getting the blocks and everything. I want to point out, if you see your node here and in the gray like this, and you're stuck at block 0, this means that your firewall is blocking the connection between your node, and the other nodes. Make sure that all the ports are unlocked. It should be by default, but if they are not, I will send you a link to documentation where it explains what ports you need to have open. Okay, so that's kinda it. In a way, okay, that's kinda it. You need to have a node running, and it's running right now. The next step now is to actually generate some session keys. So this is a bit the mysterious part. So the question is, why AlphaNet and not mainnet? So it's basically that I don't want to spend mainnet caps. Okay, AlphaNet caps, I can mint them, I can burn them, I can do whatever they want. They're worthless. Okay, if something happens, I don't know, I lose all those caps somehow, or I do a mistake, nothing will happen. It's a test. The AlphaNet is a test net. If I'm doing this example on mainnet, and for some reason I make a mistake, or send those caps to a wrong account or burn those caps somehow, yeah, I'm kind of creating a problem, okay? But again, the whole procedure, like everything, literally everything, is the same for the mainnet. There is no single difference besides, passing dash chain alphanet or dash chain mainnet. That's the only difference, okay? I suggest you, like I literally suggest you, if you want to be a node operator, try it on the alphanet first, okay? Don't go directly to the mainnet thinking that you all have mastered everything. Try it first on the alphanet. You will probably see that you made a mistake, and if you did it on mainnet, you will lose money. So do it on alphanet, try it. If it works, then do it on mainnet. Okay, so this is running. We are getting the blocks. While this is happening, I'll just open a new tab. I will so we need to SSH again to this machine because we want to generate the session keys. So I will write SSH root 163.172.184 and 128. Yeah, so I'll go back to the presentation itself. So we see our node running. It's I'll just zoom it a bit. It's getting there. No, it will take time, but it's getting there. But we can continue. So once we have that, we need to generate the session keys that I showed you guys before. It's the mixture of the 4 keys, and we can do this by calling this curl command, which you can just basically copy from the slides and paste it here, and it's going to save them in the text file called session keys. So what I will do is I will show you how it looks like. So the session keys are but they're stored in the results field, and this kind of information you need to store somewhere safe for a brief moment, because we're going to use it later, okay? So save this somewhere, copy paste it, I don't know, in a text file, or keep it here in the session keys text file. It's up to you, but we need this for the second part of the talk. Now let's go back to the presentation. Once you have generated the session keys, it's super important to stop the node with Ctrl+C. I hope it's going to work because this is live. Stop the node and start it again. Okay, so the question is, can we directly migrate existing node from testnet, or do you recommend to restart a new one from the scratch? You need to migrate. You need to start a new one. There is no way for you to migrate because they're completely 2 different blockchains, and you just cannot move from one to the other one using the same data that you have. So when you run a validator, it stores all the blocks in the node data folder, and you want to switch from one chain to the other one, all those blocks that you have are now invalid, right? They're completely useless. That's why start a new one from scratch, because it's the easiest way to do it, and the risk is going to be quite low. If you try to migrate and do some kind of magic, you're just going to cause problems. What you can do now is you can pay for a VM. You can do all your testing with AlphaNet, running the nodes, and then you can just reset the node and reset the VM completely and start from scratch and do the same process for the mainnet. Again, the process is literally the same. There's no difference, so don't be scared. Everything is going to be just fine. Okay, thank you for the question, Chris Sproles. I hope I pronounce your name correctly. So we stop our node. The reason why we stopped our node after we generated the session keys is that those session keys are now stored in the node data, and I'll show you right now. So if you go to the folder where we store our node data, and I go inside chains, and here you will see AlphaNet Live. And if I go to key store, here I have 4 files. I'll do LSA. Here I have 4 files, and those 4 files are basically my private keys are going to be used to validate blocks and to finalize them, okay? And sometimes if you don't stop the node and start it again, the system will not pick it up. Okay, that's why just stop the node and start it again, and it's just going to be fine, okay? I know it's a bit hassle, but yeah. And this is kind of it for this part, okay? You're kind of done with this. After that, you can, do the stacking part. But I want to spend at least 20 minutes explaining how to, make this system a bit more user-friendly. Because right now I showed you the way how to run the node. But if you do Ctrl+C or if you exit, the node will just stop working, right? This is not something that you want to. You don't have this behavior. You want to have a behavior where you set up the node, you exit the the VM, and it should still be running. So let's talk about this scenario. Again, this is not again, but it's inside this presentation, and it's literally the next slide. So we configure our client, we passed all the flags that we need to pass, we have checked it in the telemetry data, and it was there. And now it's time to configure the server itself. So you want to have a node which is running, and you need to fiddle with it. And if you exit from the console, it should still be running. And let's do this part. Okay, I'm not going. Let's skip this. So in order to do that, you need to SSH again to that machine. I will actually now switch to another machine because it takes a while, for to get all the blocks. And I already have a machine which has all the blocks. It's called Marco Workshop, I think, banana or machine, yeah. So I'll SSH to this machine, and then we'll continue with that machine. There is no difference there, okay? It's the same configuration, everything the same. It's just the fact that I have already a machine which has all the blocks, and I don't want to wait here 30 minutes for for my new validator to catch up. So let me just find the IP address of that machine. It's in here, okay. SSH root. Okay, now I'm in my machine. It's basically this one, Marco Workshop machine. I already have all the blocks, but I didn't do the session keys. I will do it a bit later. So what we want to do is where is my work here? So we want to make sure that the nodes, if the system gets restarted, that the nodes will start up again. We don't need to do any manual work. And we can do that by creating a systemd file or systemd service file. This is, of course, this works in most Linux machines, I think. I'm not sure about macOS. I'm not sure about Windows. I'm quite sure this will not work in Windows. But yeah, those guidelines that you can see here, those commands, they definitely work for Ubuntu-based system, Debian-based system, Arch Linux. Yeah, Arch too, but for probably Fedora too. But for macOS, I'm not sure. Yeah, so we need to SSH again. We need to create a file called Ternoa.service. Okay, in the directory etc systemd system. I already did it. So in the folder, etc systemd system. You need to create a file called Ternoa.service. I already did it, and I will just open it. So if you want to create a file, you can just write nano Ternoa.service, and it will open in the editor. And then you need to paste. You need to paste the content of this paste bin link. So you do right click, copy. You open the paste bin link. You go to the row paste data, Ctrl+A, Ctrl+C, and then you go back and paste the data in here. Just make sure that the name is something unique. Don't use the one from the paste bin because it's going to be super confusing. And make sure that the base path, or the place where you store your node data, is the correct path. Okay, I'll just make this bigger. In certain cases, you want to have this node data stored in a separate disk, which you can increase or decrease. In that cases, you need to use a different path. Okay, but the other flags like chain, validator, state cache, and execution, they will be the same. Once you have done that, what you need to do in order to start everything, you need to write systemctl start and then the name of the service by systemctl. Yeah, it will then will start. In this case, what we will do, I will stop it for a moment. I will write systemctl status. I'll put service in here, and it will say that it's dead, so it's not running. Once you do, oh my god, I will hide this. Once you do systemctl start, and when you do status, it needs to be green. So this guy needs to be green, active and running, and in the console everything should be okay. There should be no errors. This means that your node is running correctly, and in order to see what kind of logging messages it shows, you need to, instead of call systemctl, you need to call journalctl -u, the name of the service, which in case is Ternoa, and then -f. Then you will get the latest messages that the node itself has generated. So to recap, in order to have a system where you don't need to manually fiddle the node every time a system restart happens or every time you close the terminal, you need to generate the systemd file, service file. You need to copy and paste the data from the paste bin to the service file, change the name, change the path if needed, and then just run it, and it's going to work perfectly. Okay, so there are some questions. Will there be any kind of waiting queue like during the launch of the testnet? By default, so I will talk about waiting queues later in part 2, but there are no waiting queues. From this perspective, from the node operators, from the DevOps perspective, there is no waiting queue. Waiting queue is something regarding how staking works and how election work, and we will discuss that in the second part. But for this part, we can just continue. Okay, guys, yeah, okay, that's it. Since in using this machine I didn't generate the session keys, I will do it right now once more. But yeah, so it's going to be SSH root and then 163.72. I mean, this is live. If something happens, it happens. I will need to debug it, but I think they're not going to have any problems. So if I go back to the slide, and if I go back to the slide where I explain how to generate the session keys, copy, paste, cat session keys, okay, and I will open my notepad, and I will just store the session key here because I will use it later. Okay, and like I said, you need to stop the node. So if you are running your node using the service file, again do systemctl stop and check the status. It will say it's inactive date, and then just do start. There's a command to reboot, but yeah, this can work too. Okay, so we have our node running. We generated the session keys, and literally now you became a node operator. So congrats to you guys, kudos. You just became a node operator. There's nothing more to do after this. If you're a DevOps guy, that's basically it. If you want to make the machine more secure, if you want to do some telemetry, you can do. But from the perspective of a node operator or a DevOps, you are done. There is nothing more to work on this phase. Okay, on with VM. Everything else that we're going to do, so in the second part, we're going to do through Polka UI. Okay, this is going to be the part where we're going to stake. We're going to be part of the election, and then combining that, so staking if you combine that with running a node, you will get you will become a validator in the full sense. Okay, so the node operating part is done, everything works, we have all the blocks, we generate a session keys, and now we will take a short break, like 5 minutes for me to relax a bit, and then we will do the next part, which is probably going to be quite short, 15 or 20 minutes, and after that we will do Q&A. And then, guys, of course, you can come and join the podcast. We can talk about anything, because this is the coffee break. Okay, the goal of the coffee break is to relax and talk about interesting stuff. Yeah, so let's pause for 5 minutes. I'll drink some water and we'll get some air, and then see you guys in 5 or 10 minutes. Okay, I will do that. I will remove. I will remove myself. See you guys in 10 minutes. And are we back? Oh, hello, Masternodes. Can you hear me, Masternodes? Can someone hear me? Let's see if that part works. Yeah, so great. So for people who just joined, we have finished the first part of the workshop. Basically, we run our node, we configure the node, we run it, we have setups of automation script, and now it's perfectly running. Yeah, so the replay is going to be, so this right now is live on Twitch. Sadly, it's not going to be on Twitch. We're going to upload it on YouTube. So this whole stream is going to be available on YouTube probably tomorrow in the morning. Yeah, no problem. Yeah, okay. So for you guys who just arrived, I don't know, half an hour ago or 1 hour ago, we are actually running a game where you can win prizes or a prize. So I'll just share my screen for a moment. Yeah, I can just do that. Yeah, so the game is like this. So you need to visit the Ternoa.com slash team website. I will send the link to the chat, and you need to find the most handsome guy in here. Okay, it needs to be just one. Okay, and once you find him, you need to send his name to either Ternoa or Telegram. Make sure that you quote or do a hashtag handsome, but you don't need to do, and do it on Discord. So do it on Telegram or Discord. Just state the name of the most handsome guy in here, and you will be in a pool, and you will have a chance to get a prize. So the prize is basically, I will send you a postcard from Croatia. This is the prize. I know it's amazing prize, but yeah, it's a start. Okay, so we're going to have 3 winners. The first person who answers it correctly, yeah, the first person who answers it correctly will of course get a postcard. Then one of the correct people who have correctly answered will get a prize, and then the third category is people who have wrongly picked the most handsome guy. They will still have a chance to get a postcard. So everybody's a winner, even if you completely tagged or wrote the wrong name. You still have a chance to get a postcard from Croatia. Imagine that. So if you have never been in Croatia, it's an amazing place. Okay, let me just summarize once more what we did in the first part. The goal was to go through some of the terminology that we use in this node operating space, like validators, clients, nodes, runtime, storage, runtime upgrade, WASM, all those kind of keywords. We went through them. I did my best to oh yeah, maybe I should show the workshop. I did my best to present you what it means, how it looks like, and I think I gave an example of that a human brain is basically the WASM runtime, and it's kind of the same. I will share the link again for all the new guys in the chat. And after that, we went to the workshop part where we created created or downloaded the binary, configured the binary, run the binary. We saw that it was working, and then we configured the server so the binary or the client or the node is run every single time when a system restart happens, so you need to run it manually. And once we're done that, we became official node operators, and your job is done. So if your job description in your company is node operator, you're completely done. You don't need to do anything anymore. And now comes the second part of actually being a full validator, and that's that you need to stake your funds in order to have a chance that your node becomes active one. So this is not something that we discuss. I don't have a presentation. I don't need a presentation for that because the Polka UI will be used as a way to communicate with you guys. So so don't forget, we have the session keys. Make sure that you have stored them. We're going to use them quite soon. Okay. Let's talk about staking. So there are two ways how we can stake. Okay. Currently in our system on Polkadot and Kusama 2, and I'm not sure about Moonbeam. It's basically you can either stake as a validator, so you stake a certain amount of funds for your node, or you can stake as nominator, where you say basically I trust those guys and I will stake a certain amount of caps. And you can see here as an example, this person or this node, this account is active validator. I'll talk in a second what this means, and people are backing him up. Now, if your question is which node to choose if you want to build a validator, sadly, I'm not really the best person to talk about that, but make sure that you trust this node, okay? Don't just back up the highest guy because you might get burned. Okay, let's talk about, so the question was, are we going to be in the waiting queue or not? So it's not really a complicated topic, but I think I'm having a hard time to convey my message properly, even if this is quite simple. So they are basically two types from the UA perspective. Okay, there are two types of validators. There are active validators. Those validators, they participate in block creation and for block finalization. And then you have the rest. Okay, then you have just validators who are in the queue. Okay, what this means? This means that after every 24 hours or 12 hours, a new set of active validators will be chosen. Okay, a new set. And depending on how much caps you have staked or how much caps have people staked on your node, you will be either in the active set, so you'll be making blocks and getting paid, or you're going to be in the queue. This is a rock solid system, and basically your goal is to have the highest amount of stake, but enough staked caps to be in the top, in this case top 5. Okay, so if you're running a validator, so I'll just go to targets. So if you're running a validator and you have staked 150, let's say just 150, that's all, then you're going to be in the waiting queue forever. You need to stake more than the last guy in the active validator list. So in this case, I will just total stake. In this case, you need to stake more than this guy. So if you stake more money, either you or people nominated, then you will be part of the active validator in 1 year, I think. So either 12 hours or 24 hours. Okay, that's the only reason only way how we can go from queue to being active validator. That's the only way. There is no other way to do it. Okay, if you're in the queue, you're not earning anything. Okay, just you as a validator being in the queue, you're not producing blocks, you're not finalizing blocks, you will not get rewards. Okay, you need to stake enough of funds, or people need to nominate enough funds to your validator, and if you're part of the top 5 in this case, you will be producing blocks. Now, right now, for security reason, we have just 5 active ones, okay, and 1 waiting. So Arna Woodpool, I apologize for mispronouncing, unable to write in Ternoa English. If you just joined, you can, but you need to press the button. So there is a button when you join the chat, you will see a button which you need to click under 1 minute, I think, or about a half minute. It says unmute me or something. I don't know if this is how Telegram works, I guess. I don't know. I'm not really using Telegram, but you need to click this button to enable to write. Or if you have Discord, you can write in Discord, and I think there is no kind of There's no security like that there. Okay, so let's continue. So again, to summarize, you need to stake more than the last guy, and then you will have the chance to be activator. That's basically it. Example I will give is our testnet node. Here you can see that we have 12 active ones and 334 waiting. Now this is a huge amount of nodes that are waiting, and in this case we would increase from 12 to, let's say, 100. Our ratio of 3 1 or 1 3 ratio is, I think it's a perfect one. I can give you an example of other chains how they're doing it. So if you go to Polkadot and we go to the staking one, so the validators are active ones. They have 300 active and they have about 700 waitings. So again, this is okay. This can work. There are enough active validator slots for anyone to become. And if you go to Kusama, you will see that they have 1,000 active validators, and in the waiting queue they have 1,000 more. So in total they have 2,000 nodes. Half of them are active, half of them are inactive. We will see. In the end, it's going to be your choice how many active validators we're going to have. It's the choice of the community, but you will see that we will try to keep, at least from our perspective, this 3-1 or 1-3 relations. So for one active validator, we're going to have 3 waiting, just to make sure that the system is stable. If we have too many active validators and too little in the queue, there might be some instability happening in the chain itself. That's why you always want to have enough nodes in the waiting queue, that in cases that half of them die for some reason, you still have enough to replace existing ones. Okay, I hope I answered your question. Where are you? I think it was, I forgot. I hope I answered your question. You're going to be in the waiting queue if you haven't staked enough caps, basically. That's it. There is a limit, a minimum limit on how much caps you need to stake. It's 150k, so 150,000 caps. That's the minimum amount that you need to stake in order to be a staking validator. For nomination, there is no limit. No, there is no upper or lower bound. You can nominate 1 cap, you can nominate 1 million cap. It's just going to be fine. Okay, so what we're going to do right now, so we're going to become a staker, and we're going to be a validator staker. We're going to do this. There are a couple of ways how to do this. I will do the most simple one, and that's basically by pressing this magic validator button. Okay, once you press this, I'll just I forgot to send the link to the UI itself. Just give me 1 second. I can directly go to where are you? Here. So this is the link to the UI and the place where you can actually click on the validator button. You're not going to see those buttons if you don't have a single account. Okay, you need to have at least 1 account to see those buttons. This is the way how this Polka UI works. It's not my choice, it's just the way how it works. So once you click on the validator button, it's going to ask you for 2 accounts, for a stash account and for a controller account. Now, you don't need to have 2 separate accounts. No one is forcing you, okay? No one. But I recommend you guys to create a special account for stash and a special account for controller. So the difference between stash and controller is that basically the stash, you're going to store your funds that you're going to bond and that you're going to stake in the stash account. In case that something happens with the stash account, the maximum amount of caps that you can lose is the amount that you have there, okay? And since you're going to be just using it for staking, nothing bad can happen. Now imagine that you use 1 single account as your main account, and as your stash account, and as your staking account. You can lose funds, you can make mistakes, and then you can get slashed, and then you can get problems. Okay, Polkadot or Subset they recommend to have 2 separate accounts, have one controller which is going to control the stash, and the stash here is going to hold the funds. This is the recommended. Again, you don't need to follow that, but I would recommend you. So there are a couple of ways how you can create account. You can either use the Polka.js extension and click on plus and create a new account, or you can create it through this interface where you press the add account button, and then you follow the on-screen details. Now I'm going to use probably existing ones if I have probably some of those. So, or actually I will just create a new one. So I will create, please do not copy this seed. I will call it workshop controller, and use some super simple password. So this is going to be my controller account. Make sure that you store the mnemonic somewhere, because if you lose your mnemonic, it's done. You will lose your access to your account. And I will do the same for the stash. So it's going to be workshop stash account. Okay. Again, make sure that you don't lose your mnemonic, because then it's game over. Okay. I'll just refresh the page, and if I go workshop, you can see I have the controller and stash. Now you need to have some funds in those accounts. On the workshop stash, you need to have at least 150k. On the controller, you can have 1 or 2 caps. So I will just send some funds there from this. For AlphaNet, you will probably talk with our support guys. They will give you funds. For the mainnet, you need to bridge your caps from Ethereum to Ternoa or to Substrate to have those caps, or somehow buy it. Okay, I will send to controller. I will set 2 caps. Okay. And to stash, I will send 152,000 Ks. So I can go to kilos or thousands. It's going to be 152,000. Okay, so now we have enough funds in the controller. Now we have enough funds in the stash account. We can go to staking. We can go to targets. Sorry, where are you? So to accounts, we're going to press the validator button. We're going to select our stash account. We're going to select the controller. We need to make sure that we bond at least 151k. If we plan to do less, I think the extrinsic is going to fail, so we're going to do this. So we're going to do 151. Where are you? Okay, I'll do like this. 151. Now we can select where the staking rewards are going to go. Are they going to increase the current stake? Are they going to go to the stash account but not increase the stake? Are they going to controller account or a specified payment account? They're going to go to the stash account, and we go next. And then I guess hope you remember the session keys that I was talking about that you need to store. This is the place where you copy your session keys, paste it here, and then the last step is to choose the commission fee. This is kinda, I will suggest you to play with the value and Google a bit what would be the best value. I'm not really the best person to recommend you what to put in here, so take some time, Google and see what people think. And the last option is, do we allow nominations or not? If you're a huge company like Google, you might disallow nominations because you want to get all the rewards. But as a small validator, I would suggest you to set this to yes. So we click on bound and validate. You need to write the password of the stash account, and that's it. Quite simple. I know it took me like 15 minutes or more to explain that, but that's basically it now. So if you go to overview, you will see that we are in the waiting part. Workshop stage. We are in the waiting part, and after 1 era, if we have enough caps staked, if we have taken enough caps, we will become an active validator, and we will be earning money basically. This is one way to do it. So to press the validator button. I will show you the other way how to do it. Let me just stop it. Yeah, stop it. What would you do is, you, instead of pressing the validator button, you will press the stash button. Okay, now I'm explaining how to stake in general. Doesn't matter if you're going to be if you're going to do validator staking, nominator staking. This is staking in general. Okay, so if you want to stake in any of those two ways, you need to click on the stash button, select your stash, select your controller, bound a certain amount of funds, select the payment destination, click bound, and then you're going to get something like this. Okay, so you're going to have, it will say said that you staked 151k, or the amount that you have entered, but your staked funds are actually doing nothing. They're just sitting there. Okay, you need to either become a validator, that's why there is a validate button, or you need to nominate. So if I want to nominate, I will just show this case. I will pick this newly node that I don't know. I will click on nominate just this node, and after a while it will say waiting nominations, and after 1 era, which is either 12 hours and 24 hours, depending on if we're talking about AlphaNet or mainnet, we will nominate our funds, all our funds, to this node. Again, if you don't know if you want to be nominator or validator, just click on stash, follow the on-screen on-screen options. Probably it's just this is the only screen, and then you will get something like this. Once this is done, something like this, and then you can choose either to become a validator, then you need to the commission fees, and the next step you will put your session keys, or if you click on nominate, you can directly nominate, and that's it. So the part 2 is quite short. Once you have the validator setup, once you have the session keys, you kind of just need to have 2 accounts, node and validate session controller. You click this button, you follow the on-screen details, and it's done. So that's why I didn't create any kind of special presentation for this, because it's super clear from the UI itself what you need to do. In case that you really want to know, or you forgot what you need to do, or it's super confusing, I suggest to go to the official documentation of Polkadot. So if you write Polkadot run validator, it's first link here. After you scroll down, you will see basically the same. So you need to bond, in this case dot, because we're talking about Polkadot. On Ternoa we have caps. You need to bond. You have all the images on what you need to do. It explains what those fields do, and you can follow this. You can follow the session keys too. It's all the same. So this the whole workshop, it works for Ternoa, it works for Polkadot, Kusama. So in case you want to move to a different chain, you can still move it. You can use the same experience that you have to be a validator. And that's basically it. Like I said in the beginning, we didn't talk about making the node secure, setting up NGINX proxy and stuff like that. I would suggest you guys, if you want to be a serious node operator, go through the whole validator guide. Okay, we're probably going to have it too somewhere in our documentation, but it takes time to write quality documentation, and I cannot give you any specific date. It might happen on Monday, it might happen in 1 million years, someone in between. Okay. But yeah, I will send the link to this guide so you have it too, and we are done. That's it. That's how you become a node operator. That's how you become a nominator or a validator on the Polkadot, or staking nominator, staking validator. Yeah. Now, if there are any questions, guys, please leave them in comment. I will send a link to. Let me just close. Let me just remove this. Go back to me. I will send a link to this panel so that you guys, if you want to join, you can join. Let me just find, invite. So if you want to directly talk with me in the next couple of, 10 minutes, because I will be here for 10 more minutes so that we have exactly 2 hours of workshop, you can click on this link, you can directly join, and then we can talk. If you're too lazy to write, or if you prefer to talk with a human being and not to write, it's up to you. Besides that, if there are no questions, we can either close it early or talk about some interesting topics that's going to happen. One of those interesting topic is that tomorrow or the day after tomorrow, I'm not quite sure, probably tomorrow, we're going to enable the bridge, so you're going to be able to bridge your Ethereum cabs to Ternoa subsite. And next week we're going to change how our governments work. It's going to be more decentralized, so you're going to be able to do referendums and vote on changes, so you will have more power, way more power than now you have on the chain itself. But this is kind of how we are looking at it. So in the next 2 weeks you can expect 2 more runtime upgrades. I mean, this week on mainnet is going to be bridge, next week is going to be governance, and probably after that we're going to start like really soon with phase 2, and that's basic NFTs. So in the basic NFTs we're going to have just NFTs, marketplaces, and that's it. But the basic functionality and lending too, and soulbound and NFTs, the advanced version of those features are going to be in phase 4. Phase 3. So phase 2 is our basic NFTs and basic marketplaces, and in phase 3 we're going to phase 3 we're going to have advanced NFTs and maybe advanced marketplaces or marketplace, but that we will see. So again, don't forget to participate in the game. I think we have someone. It says device not connected. You need to connect your microphone or camera before I can add you to the stream. Sorry, sadly. Let's wait for, I guess you want to really join. Let's wait for you to join. While we are waiting for that, I can talk about future releases. So like I said, phase 2 is kind of basic NFTs and basic marketplaces, basic lending, basic soulbound, just basic functionality, and after that we will build advanced version of it. Why are we doing it this way? It's quite simple. We want you to provide the functionalities as soon as possible. What you usually see in IT industry, that people they have an idea and they want to implement this idea, but during the implementation they get additional ideas and they change the existing implementation, and they have more ideas, and instead of waiting 1 month to get something, you wait 5-6 months, 1 year, and it's going to be perfect, or maybe it's not going to be, but you will be waiting like one year to get something basic that you need. It's going to be super advanced, but you just need some basic functionality. So that's why we're doing separate releases. That's why we have basic NFTs and basic marketplaces in phase 2 to provide those features to you guys as soon as possible. On phase 3, I think we're going to have a discussion on our GitHub. Hi. Sadly, hi, Bullet of 50. Sadly, you just came to the end of the stream. We have just a few more minutes for questions. Just to let you know, this stream is going to be available on YouTube tomorrow in the morning. And I mean, I guess you don't have any questions. If you have any questions, please feel free to ask them in here in the chat, or if you want, you can join me on this panel and talk with me. Okay. Yeah, like Kevin said, there is going to be a replay available on YouTube. I hope you guys at least found this interesting in any way, even in in a funny way. It was a super long session. Uh, it's okay. You can try. No one is a native English speaker in here, and if you were here, you will hear me like fighting with some words, but it's fine. You can try Bullet 50. I can send you if you want to join. Again, I'm not forcing you anything. If you want to join the stream itself, the panel. Oh yeah, like Kevin said, if you, yeah, I will just do like this. Like Kevin said, if you have any tech-related questions regarding anything you saw today, you can use our Discord channel. There is a group for that, and you can ask your questions there. I would suggest you to not use Telegram for that, because what I saw is that for technical questions, Telegram is quite useless, to be honest. They are okay for really short questions regarding maybe some peer activity. Yeah, I can do that. GitHub, just give me a moment. Jane and here. So yeah, to highlight this, Chris Sproles asked, can I send the GitHub link again? And I did. It's in the chat. So the phase 3 features are going to be discussed probably on GitHub too. I'll just share my screen for a single moment. So I mean, this is just something that I started, I think a couple days ago, 3 days ago. I will add some description. So here we're going to have, or you guys going to be able to discuss what you think about the nested NFT feature. I will add way more, documentation here or commentary once I have the time, probably tomorrow or on Friday. But if you want to discuss this feature, if you think that it can be done in a better way or in a worse way, if you have some constructive, feel free, go to this link, write a comment in here. You just need to log in with your GitHub. There should be not really a pro GitHub account, and comment anything. Be constructive, please. Again, we do our best. Now time for some music. Yeah, I think I guess we can close this now. Okay. So Bulletus 50 says, before he becomes not valid, I will try to test the bridge on our iPhone testnet. I'm a beginner. I follow to know since 1 year maybe. Sorry. Yeah, definitely. So I will send the workshop presentation again because you joined really late. So the presentation itself is quite, I think, self-explanatory and easy to follow. I made it in that way that you really cannot make a mistake as long as you what you're doing. It has, I think, like 40 slides, so it's full. It's really detailed, and we're going to have this stream too on YouTube, so it's going to be super easy to follow. Yeah, let me just send the link. Okay. Yeah. Joris 90s 4, there was a workshop, a really long one. It was 1 hour and 40 minutes long, but yeah. Anyway, thank you guys for being here. You're really amazing. We're going to have tomorrow. So on AlphaNet you can already do it, okay? There are all the guys who are doing that there. I just show you if you were following the workshop, I already did it on the AlphaNet. For the mainnet, you can already do it, but since we don't have the bridge, you cannot bridge the coins from Ethereum to Substrate. Once the bridge is up, which is probably going to be tomorrow, you will be able to run a validator. Okay, you can already set up everything. You can set up your node already right now for the mainnet, but the staking part, since you don't have the caps on mainnet, you need to wait for the bridge. Okay, so to all of you guys, you already can run your node. Okay, you already can do that right now for mainnet. You just need to wait for the bridge to open so that you can bridge the caps and do the staking part, because that's why the workshop was in two parts. You have the node operator, and then you have the staking part. But yeah, I hope this is now clear. I saw those messages before. I might not have conveyed the message properly last time, but this time I hope. Yeah, so if you have an AlphaNet, you can you can do it on mainnet right now. So this second you can do it. You just need to wait for the bridge to bridge the caps. Okay, so that's all, guys. Thank you for being here. Have fun. Please like, subscribe, ring the bell, whatever, and see you next time. Don't forget to send to Telegram or to the Discord what's your most handsome guy in Ternoa to win a prize like a postcard from Croatia, and that's all. Bye bye.